We have been discussing about attitude dynamics, so we will continue with that topic. So, in the last lecture we are looking into the Euler angles. So, in the Euler angles basically we had the angles psi, theta and phi, which were used to describe the rotation in an inertial reference frame. So, in that context we were looking into this picture. Okay, so, the first rotation was given about the C 3 x and here we got psi dot and this angle we wrote as psi. Then the next rotation was given about this x and this x we can write as E 1 prime. Okay. So, after the rotation the resulting x was so the rotation from here to here, this is theta. Once we are rotating from here to here, so your E 2 x will also rotate by the same amount and this angle from here to here, this is also psi. Okay. So, once you rotate, okay, so this is your E 2 prime and we have the E 3 prime here in this place itself. So, once you rotate it, it will rotate up from this place. So, this is rotating from and going from here to here. So, it will move from this place to this place. And this you are rotating by angle theta, you can write here E 2 double prime. Similarly, here this will be your E 3 double prime and in this place itself you can write E double prime, E 1 double prime. Now, the third rotation we give about the E 3 double prime x and that rotation we give by angle phi. So, if you rotate by angle phi, so you can see that okay, now I will make it solid, make this line solid to represent that this is lying in this the plane constituted by this blue line and this green line. Okay. So, basically the inclination of the this plane which is shown by the green line, this is with the E 1 E 2 plane, this is nothing but theta. Okay, and maybe we can make it little this is lying in the same plane. So, this will be better represented like this. Now, once you rotate it by angle phi, so the next rotation will be this line will the line from O to E 1 prime, this will rotate by angle phi and this we can show somewhere, let us say this is your coming to E1 triple prime, and similarly this will rotate also by angle phi, and it will move away from this place to this place, and this is E2 triple prime. And these are the orthogonal axes, remember E1 prime and E2 prime, and E3 prime, and E3 prime will be here in this place itself. So, E1 triple prime, E2 triple prime and E3 triple prime, they form a orthogonal axe. So, the angle from here to here, this one is, this black angle is, this is 90 degree. Okay, so, what we have done, we have given 3 rotations. So, the first rotation we gave about the E3x. Okay. So, any rotation, let us say that we have the E1 and E2 here, okay. And if you rotate it, rotate this x and write this as E1 prime and this as E2 prime, and if you are rotating it by some angle, say theta, okay, then it is possible that we can describe the transformation from one reference frame to another reference frame, and we will be rotating about the x E3. So, we are rotating about this by theta. So, theta dot is in this direction, and these two are rotating and coming into this place. So, the resulting components in this direction you can write as E 1 prime is equal to E 1 cos theta plus we have to take the component of this E 2 cos 90 minus theta. This is the angle from here to here, 90 minus theta. E3 sin theta. Similarly, you can write E2 prime, this is E2 prime. So, E2 prime will be E2 cos theta, and we have to take the component of this along this. So, this will be E1 cos 90 plus theta, and this gives you minus E1 sin theta plus E2 cos theta, while E3 prime you can simply write as E3 because you are rotating about this. So, there is no change. So, basically any vector whose components are E1, E2 and E3, or say if they are unit vectors. So, the components of the unit vector, these are E1, E2 and E3. So, you can rotate them and describe them in another. If you rotate them, so it can be described as the another components can be written as after rotation. So, E1 prime, E2 prime, E3 prime. So, from here you can see that if you have rotated about the E3x, so E3x there is no change. E3 prime is just E3. So, from here we can write E3 prime is equal to E3. Okay. Completing this matrix, E1 prime can be written as E1 cos theta. So, here you have cos theta and E3 sin theta, then we have this is E2, sorry, this is E2 sin theta. So, we have sin theta here in this place, and E3 term is not there. So, here we put 0, and then from this place we have minus E1 sin theta. So, this is minus sin theta, and then E2 cos theta. So, we put cos theta here, this term is 0. So, this is your rotation matrix or the transformation matrix which rotates from one reference frame to another reference frame. Okay, so, we have given rotation about the E3x. So, in most of the cases we have chosen the axis like E1, E2 and E3 in this way. So, if we rotate about E1 x, E2 x and E3 x. So, simply we can write as rotation about E1, it can be written as E1 prime, E2 prime, E3 prime. So, if you are rotating like this using, if you are rotating about E1, so you will have 1 here in this place, because this vector will not change, this component will not change, and we will write here E1, and rest other things you can write as, say if you are rotating first by the about the E1 x by, let us say, by theta. Okay, you are rotating about this. So, if you are rotating by theta, so this becomes cos theta, sin theta, minus sin theta and cos theta. Rotation about E2, similarly we can write as, let us say, another notation we use here. Let us say E1, E2 and E3, and now we are rotating about E2, and therefore, E2 will remain unchanged. It will, E2 will be equal to E2. Okay. And let us say we want to rotate about this by some amount phi. Okay, so we will write here as cos phi. Okay, see the sign change we have done here. Here this is minus, in this case it was plus here diagonally for the sine. For the cos it remains same, but sine here, for the sine it has changed. Again if we rotate about let us indicate this vector as alpha 1, alpha 2, alpha 3, and this we rotate by psi. So, we are rotating about E3 now. So, this remains unchanged and rest other will change. So, we will write here cos psi minus sin psi here, cos psi 0 0. Okay, so, you can check this, this is very simple, you do it as an exercise yourself. Now, coming back to this figure. So, what we did in this figure, that we first rotated about the E3 x by angle psi, then about the resulting this even rotated and came from here to here. So, the resulting x axis, this is now, this is basically the x axis and this is y and z axis. So, we have replaced that notation by E1, E2 and E3. So, after rotation it comes to this place. Now, if you give the rotation by theta, so this theta is shown to be here and this angle comes to this E3 rotates and comes to this place. Okay. And the next rotation we are giving by psi. So, once we give the rotation by psi, so this we have not shown the angle here, this is your angle psi, okay. And the angle from here to here, this is psi. You should remember that theta and psi, they are not in the same plane. Okay. Theta is the inclination of this plane with respect to the E1, E2 plane. while psi is lying in the plane over which I am running my pen here over these lines. Okay, so, now we have the 3 rotations. So, the same way we start with the E 1, E 2 and E 3 vectors. So, finally, what we need that after the rotation, what will be this transformation matrix, which will be giving us the final configuration, where we have written this as E 1 triple prime, E 2 triple prime and E 3 triple prime. This we need to find out. Okay. So, for this the first rotation you give about the psi. Okay. So, first about the E 3 by angle psi. So, E 3 you are rotating about the E 3, if you rotate by psi. So, this will be cos psi, sin psi and minus sin psi, cos psi, E 1, E 2, E 3. So, the resulting vector, now it will be operated by another rotation or the transformation matrix, which will be a result of this rotation theta about this resulting line E 1, E 1 prime. Okay. So, once we rotate it here, so the next rotation, this will be operated, this is basically giving you a vector. So, this vector will be operated by another rotation, which you are giving about the E 1 prime x. So, here this will be 0 0 and you are rotating by theta angle. Okay. And finally, this will give you again a vector. Now, once again you need to rotate to come to this position, E 1 triple prime, E 2 triple prime and E 3 triple prime. So, here you are rotating and this is your phi dot, and in this direction you have already got theta dot. Okay, psi dot we have already written here, this is psi dot. Okay. So, once you rotate by this angle phi, and that rotation again we are giving about the E 3 triple prime x, and all these are the orthogonal rotations. So, this rotation is by phi angle phi. This is sine, is minus sine here, minus sine phi, cos phi 0 0, right here, minus sine phi. Okay, so, this gives you the final vector, which is E 3 triple prime, E 2 triple prime and E 3 E 1 double triple prime. And once you multiply this, so this is the total transformation vector that I was looking for. So, the transformation matrix T, what rotation, the sequence of rotation we have given, this was 3 1 3. Okay. And this is being operated upon E 1, E 2, E 3, this is the vector components, and then you are converting into E 1 triple prime, E 2 triple prime and E 3 triple prime. So, T 1, T 3, after the matrix multiplication, if you multiply the matrix and we use the shortcut notation, this cos phi can be written as C phi. Similarly, sin phi you can write as S phi. On the other hand, we can write sin theta as S theta and cos theta as C theta. Similarly, we can use the notation for sin psi as S psi and cos psi as C psi. And if you multiply, so this will yield you C phi C psi Okay, so this is the transformation matrix which will transform from here to here. So, now we have the rotations here. Already we have written that omega, this is equal to omega 1 E 1 cap plus omega 2 E 2 cap omega 3 E 3 cap, where E 1 is identical with E 1 triple prime cap, E 2 cap is identical with E 2 triple prime cap, and E 3 cap is identical with E 3 triple prime cap. So, going back into this figure, now you can see that in this figure we have psi dot along this x, theta dot is along this x, and phi dot is along this x, and we want to convert into all these along the in terms of omega 1, omega 2 and omega 3. So, omega 3 is being taken here, omega 2. So, omega 3 is along this direction and omega 2 is along this direction, omega 3 here, and this is the your omega 2 and omega 1 is along this direction. So, these are the three perpendicular directions. Okay. So, an angular vector is broken along these three perpendicular directions, which are the final directions. After all the three rotations, these are the final orientation. So, if you want to convert from psi dot, theta dot, phi dot to omega 1, omega 2, omega 3. So, you need to convert each of the rotations each of the rate individually into omega 1, omega 2 and omega 3. That is omega 1 we can write as omega 1, omega 2, omega 3. We will have a component once we decompose this. Okay, take the components along the E 1, E 2 along the E 1 cap direction, E 2 cap direction, E 3 cap direction. So, we will have the components omega 1, omega 2 and omega 3, and to indicate that this is due to the rotation psi about the E 3 x, we will put here the 3 notation. Okay. Similarly, if we have the theta dot, so theta dot will have the components omega 1, omega 2, omega 3, and because this we are rotating about the E 1 prime x. So, here we will put the one subscript to indicate that this is because of the rotation theta about the E 1 prime x, and this will be the components along E 1 cap, E 2 cap and E 3 cap directions. and similarly for the phi you will have omega 1, omega 2, omega 3 cap, and this will be along the E 1 cap, E 2 cap and E 3 cap directions. So, ultimately what you need to do that omega 1, omega 2, omega 3, this you can write as with subscript 3 here. Remember this subscript we are putting here, omega 1, omega 2, omega 3, this is for 1 and again omega 1, omega 2, omega 3, this is the final rotation. Okay, so, this rotation, this is for you are rotating for the side, okay, this you are converting for the psi dot, this you are converting for the theta dot and this you are converting for the phi dot. So, this we will take it up and this will be shown by 0 0 psi dot. So, we make it a vector, okay, and then this is to be operated upon, we are giving the rotation psi. So, this become cos psi, sin psi 0 minus sin psi cos psi 0 0 0 here in this place. So, this is the rotation about the E 3 x you are giving. Okay, now, next rotation. So, you are rotating this vector psi dot is a vector in the present reference frame, which is shown by this line, okay, this line, this line and it is shown by. So, first we rotated by psi. So, it resulted the reference frame came to this place and from here it came to this place E 2 prime. Okay. So, the next rotation you will give as theta, which will bring into this place. We will have to stop again. Working out this omega angle, okay, we will make another figure to make the concept clear. Even that figure has become too complicated to indicate anything now. So, we have this E 1, E 2 and E 3. First rotation we gave by psi, okay, and therefore, the resulting axis what we are getting here, this is E 1 prime and this E 2 will move, and we can show it on the back here, E 2 prime and E 3 prime will be here in this place. So, this has rotated by angle psi here. So, psi dot will be present here in this place. The next rotation we are giving by. So, remember this is a psi is a vector, psi is directed along the E 3 direction and we can put the cap to indicate that these are the unit vectors. Okay, so, we can put a cap here to indicate these are unit vectors. Okay, once we do this, so you can see that psi is directed along the nu x, psi dot is directed along the nu x E 3 prime. So, we have the reference x now E 1 prime cap, E 2 prime cap and E 3 prime cap, and along which the third direction, which is the equivalent to the z direction here. So, your psi dot is pointing, and you want to convert it into the omega 1, omega 2, omega 3. So, we need to work little more further. So, the next vector is, once we rotate next by angle theta about this. So, the theta dot turns out to be in this direction, okay, and this will rotate by theta. So, this will move from this place and finally, you can show it in this plane. So, basically any line which was lying here any point. So, it will move up and come in here in this direction, and in this direction you will show the this as the E 2 double prime, and similarly this point will move away from here and this will be your E 3 double prime, and this is also the angle here theta. So, psi dot we can indicate as a vector, psi dot we can write as psi dot here 0 0. So, this is a vector which is in E 1 prime, E 2 prime, E 3 prime x, and that has to be converted along the final x. So, we have one more rotation is remaining. So, the next rotation we will give about this x by angle phi, and this is the rotation that we are giving. So, after the rotation this E 1 here we have the finally once we give this rotation. So, E 1 cap double prime is also in this direction. Okay, so, this will move away from this place to somewhere else, and that we will show by this red, green and blue line we are using for this. So, this point will move from here and it will come here in this place. So, here we will write as E 1 triple prime cap. Similarly, this will move in this plane shown by this red line, and it will come here somewhere in this place. So, this we show as E 2 triple prime, and the third rotation we have given about this x. So, this is E 3 triple prime. Now, all this, so the final orientation is E 3 triple prime, which we will indicate by E 3 triple prime cap. This will indicate by E 3 cap to indicate this is the final body x. This is also called sometimes the body x, because with respect to an inertial reference frame we are trying to orient the body. So, this is called the body x. So, this is the third direction E 3 cap, and the E 2 direction is coming here in this place. So, here we will have E 2 cap, and this is giving us the E 1 cap. Okay, so, now you can see that after giving these rotations, here this is the angle from this place to this place, this is your phi angle, from here to here this is your phi angle. Okay. This angle is 90 degree, this blue to blue line, this is 90 degree. Okay, so, this psi dot vector need to be converted finally into E 1 cap, E 2 cap and E 3 cap as. So, convert it, the first rotation you need to give is theta, another rotation you need to give is phi. So, it will get oriented with the this E 1 prime, E 2 prime, this E 2 prime is here, and E 3 prime is here in this place itself. So, this will get oriented with the next one E 2 double prime and E 1 double prime and E 3 double prime. So, this is one rotation required, and the next rotation required is by angle phi. So, we will write this as, we have the psi dot vector, this is psi dot, this is 0. Okay, first rotation we give about the x 1 x by theta angle. So, this is cos theta, sin theta minus sin theta, cos theta, and this is 0 0. Okay, the next rotation you need to give is about this x. So, this is the rotation you are giving here by phi. So, this is your phi dot basically. So, by rotating by phi about the 3. So, this will be cos phi sin phi 0 minus sin phi cos phi 0 0 0. Okay. And this will give you the components along the E 1 body x, E 1 E 2 and E 3, which is the final body x. So, we will write omega 1, omega 2, omega 3, these are the components, but this is only due to psi, to indicate this is due to psi, due to psi dot only, due to psi dot only. Okay. Finally, the next one is our theta dot. So, theta dot we need to convert, and theta dot the rotation we are giving about the 1 x, we are rotating about this x. So, here we write theta dot 0 0. Okay, and theta dot, if you have rotated now about this x. So, you can see this is along the E 1 double prime direction, and this x can be described as E 1 double prime, E 2 double prime cap and E 3 double prime cap. Okay. So, and theta dot is directed along the direction 1. Okay. Now, this is to convert it into the final x, which is E 3 the body x. Okay. This is to be converted along the body x. So, if you try to convert it, what rotation is required? This only one rotation is required. This is by angle phi. Okay. And that you are giving about the E 3 x. The third x basically you are giving. So, third x means here this is cos phi sin phi 0 minus sin phi cos phi 0 0 0, and this gives you omega 1, omega 2, omega 3 due to theta dot only, due to theta dot only. Okay. Similarly, we can do the final orientation. So, final orientation we have the phi dot here, which need to be converted into omega 1, omega 2, omega 3. So, you can see that the final orientation, this phi dot is nothing but it is a oriented along E 3 cap direction. So, we need not do any transformation, or either you can say that you are multiplying a vector by a unit matrix. So, finally, you have the rotation which is given along the third direction. Okay. So, this phi dot you can represent like this, phi dot 0 0, and this need to be just multiplied by a unit matrix, and that will convert it into omega 1, omega 2, omega 3 along the body x along the body x and is due to phi dot only. Okay, so, at this stage finally, what we need is to add up all the components. So, adding all the three so, we have these two here and this is the third one. So, we need to add it up. So, you can see that omega 1 can be written as, first we need to multiply this. So, if you add them up, this will give you theta dot cos phi plus psi dot okay. So, this is the first equation. The second equation we can write as omega 2 equal to minus theta dot sin phi and the third one can be written as psi dot cos theta plus phi dot. So, what we have done in getting this, basically we added omega 1, omega 2, omega 3 due to psi dot only plus omega 2, omega 3, omega 1, omega 2, omega 3 due to phi theta dot only and 1 omega 1, omega 2, omega 3 due to psi dot only, and this is giving you the final value of omega 1, omega 2, omega 3, which is oriented along the body x E 1 cap, E 2 cap, E 3 cap. So, this gives you the final orientation. Now, these three equations 1, 2 and 3 you can write in the matrix format. So, we can write it as omega 1, omega 2, omega 3 these are the three components, the Euler components. So, psi dot, phi dot and theta dot, we can write it like this, or any sequence you can make it here in this place, and accordingly the entries here, the elements of this matrix will change. So, this will become omega 1, you can see from this place, this is theta dot cos phi. So, theta dot is the last entry. Okay. So, here we can write cos phi and phi dot is not picturing here. Okay. The another one is psi dot sin phi times sin theta. So, this is sin phi times sin theta and theta phi dot is not picturing. So, for this we put here 0. Okay. So, the next one omega 2 is minus theta dot sin phi. So, theta dot again and sin phi. Theta dot is the last entry. So, we will put here as minus sin phi. Okay. Then we have psi dot cos phi times sin theta. Psi dot is the first entry. So, we put here cos phi times sin theta and phi dot is not appearing anywhere in this equation. So, we put again here in 0. Lastly, the omega 3 which is psi dot and phi dot. So, psi dot is multiplied by cos theta, this is the first entry, and phi dot, this is only one will appear here in this place and last entry will remain 0. So, this is easily constructed. So, this is how psi dot, the Euler rates are converted to the body rates. These are called body rates. This is the Euler rates. Okay, and vice versa, to get psi dot, phi dot, theta dot, you need to invert this matrix. So, if we write this as the T matrix, so this can be written as T inverse omega 1, omega 2, omega 3. Okay, so, through inversion you can do it, or either simply these equations are there. So, you just have to do little bit manipulation and write this equation in terms of omega 1, omega 2, omega 3 instead of theta dot, psi dot and phi dot. So, if you do that, so psi dot, theta dot or phi dot and theta dot, this can be written as 1 by sin theta times sin phi cos phi 0, and then minus sin phi cos theta and minus cos phi cos theta sin theta. Sin theta minus sin phi, this to be multiplied by omega 1, omega 2, omega 3. Okay, so, through this is the conversion equation from this will give you all the conversion equations, and alternatively you need to describe the psi dot, theta dot in terms of omega, and you will finally get the same kind of equation. So, if you try, you will see that the psi dot can be written as 1 by sin theta times omega 1 times sin phi plus omega 2 times cos phi. Okay, let us say this is the equation number 4, and similarly you can write this step I am skipping to save time. Theta dot can be written as 1 by sin theta times omega 1 cos phi sin theta minus omega 2 sin phi sin theta. Okay, here I to make this 1 by sin theta common, I introduced sin theta inside. Okay, this step you carry out yourself, this is not very difficult. Okay. And finally, the phi dot also you can write as 1 by sin theta. So, here in this case also I am taking in the denominator sin theta outside, and therefore, I will be introducing inside the sin theta factor, and this can be written as omega 3 sin theta minus omega 1 sin phi minus omega 1 sin phi and cos theta minus omega 2 cos phi into cos theta. So, in all the places sin theta is not appearing here, those are the terms which get cancelled out, they will not appear here in this place. So, you can check this equation yourself. Now, if you want to check with the equation that we got after matrix inversion, here this is the equation. So, you can check here. Let us say this is the this contains all the 3 terms, and this constitutes your phi dot. So, phi dot you can see this is 1 by sin theta multiplied by minus sin phi times cos theta minus sin phi times cos theta multiplied by W 1. This is the first element here. Then minus cos phi times cos theta multiplied by W 2 minus cos phi times cos theta multiplied by W 2. This term is here. Okay. And the last term is sin theta multiplied by omega 3. So, you see sin theta multiplied by omega 3. Okay. So, this just need to be rearranged and this is easy to work out, but this is how the conversion is done from one reference frame to another reference frame. Okay, so, finally, we are ready for doing some elementary treatment, which is in the scope of this course. So, what we will try to do the torque free rotation of a rigid body. So, we will look into the dynamics of a rigid body once it is torque free. So, let us consider that a cylinder referred to the inertial reference frame E1 cap, E2 cap, E3 cap. Okay, as earlier we have indicated. With respect to let us consider a cylinder referred to the inertial reference frame. Okay. We want to describe the motion of the cylinder in terms of body x, which is aligned with the principal axis of the cylinder. Okay, so, the body x is aligned with the principal axis of the cylinder. So, in that situation you describe the describe the motion of the body. So, what here assumption is that it is a torque free, that is t equal to 0, this is torque free. So, this simply implies that the angular momentum of the body h will be a constant. Okay, so, for convenience let h is aligned along E3 cap. Okay, so, it is aligned along the E3 cap axis, where E3 is the inertial reference frame z direction. Okay. Let omega is equal to omega 1 E1 cap plus omega 2 E2 cap omega 3 E3 cap is the angular velocity of the body, where omega 1, omega 2, omega 3 these are the body components, the components of the angular velocity taken along the body x, which is in this case the principal axis. And Euler rates are psi dot, theta dot, phi dot. Now, we can construct the figure and look into the how the cylinder is oriented with respect to the how the cylinder is oriented with respect to the body, with respect to the inertial reference frame. So, time is getting up. So, we will consider it next time, but whatever the 1-2 minutes is remaining, we will try to look into this. So, we can have a cylinder like this. So, the cylinder, the body x can be oriented, let us say one along this direction, another along this direction. This is the center of the cylinder. Okay. So, this is your E1 direction, this is E2 direction, and this is the small E3 cap direction, and the inertial ax you can show along any of the 3 directions, like the E1 cap, E2 cap, and E3 cap. Okay. So, by giving these 3 rotations psi, theta, and phi, this has been oriented from the red color directions to the black color directions. Okay. Red color x to the black color s, which is this is constituting the body x, and this is your inertial x. Okay. So, next time we will elaborate on this and look into the torque free rotation of the body and also the stability of such a system. Thank you very much.